For this lesson, I've combined two sections in your textbook together, 8.2 and 8.3. Basically, we're proving that triangles are similar. So our essential question is, how can you prove triangles are similar? And I just kind of did a whole summary for you. So you're still going to probably want to look through your textbook, but I've outlined, or I've put here in the very beginning of the lesson, here are the three ways that you can prove triangles are similar. So the first way, let's see, I had a highlighter, but I've lost it. Oh no, here it is. The first way that you can prove that two triangles are similar is if they have two angles that are congruent. Okay, so the first one is what we would call angle-angle similarity theorem. That's what the AA stands for. So basically you have to have two angles in one triangle congruent to two angles in another triangle. And if that's the case, then obviously their third angles will also be congruent. And then we know that the two triangles will be congruent. And if you remember from our last lesson, this right here is a triangle similarity statement. Okay, so this is a similarity statement. That little tilde sign, sometimes you see that in Spanish class, like above your ends or something. That tilde sign basically means similar. Okay, so one way to prove that two triangles are congruent, or sorry, are similar, not congruent, similar, is that basically both angles, there are two angles that are congruent to each other. Okay. The next way is to show that all three sides are proportional to the other three sides. Okay, so that's the side similarity theorem. And basically what you can do is you can take any side, so AB and DE, set up their scale factor, or a ratio of those two sides, and set it equal to any other two corresponding sides. So like side BC and side EF. Notice we set up the ratio of those two sides. Now when you're setting up these ratios, it's always important to think of scale factors like image over pre-image. So in this case, we would say that ABC is the image, DEF is the pre-image. Okay, so side similarity theorem. If all three ratios of the corresponding sides are in fact equal to each other, then you've got similar triangles, and you'd have a similarity statement. Okay, and the last one is side angle side. So if you know that there's one set of corresponding angles that are congruent, then you can just basically set up a proportion of two corresponding sides in the ratio. So for example here, I know that angle A and angle D are congruent. So instead of having to set up three ratios and set them equal to each other, I can just do two. So they did AB and DE, put those one on top of the other, and then also AC and DF, put those one on top of the other, set those equal, and a good way to check this again would be like cross multiplying. Okay, so that's the side angle side similarity theorem. Okay, so you guys have a bunch of examples that I'll let you do with your textbook. So you have example 1, this comes from 8.2. Example 2 also comes from 8.2. Example 3 also comes from 8.2. And then notice down here, we get into 8.3, which has an example 1, 8.3 example 2, and 8.3 example 3. So just to be really clear with you, let me show you what I'm talking about. I'm going to use my online textbook. So here I'm in I believe I'm in 8.2. Let's just double check that. Okay, so 8.2 is right here, and you would have then example 1, which will be on this next page. So example 1, example 2, and example 3. That's all with 8.2. Okay, and that takes you up to example 1, 2, 3. Then down here, you're going to need to go to the next section in your textbook. So getting to 8.3, Here's all the exercises for 8.2. And I'll assign that on the calendar for you. Okay, so now I'm in 8.3. So here's example 1. You also have example 2 and example 3. So here's example 2, and here's example 3. All right.